I'm very pleased to now introduce our fifth speaker for today, and the last one for this particular session, Professor Peter Vuillermin. Professor Vuillermin is a general paediatrician and is the Director of Research at Barwon Health. He is the Chair of Medicine at Deakin University and also holds an NHMRC Career Development Fellowship. Professor Vuillermin co-leads the Barwon Infant Study, in which his team have assembled an in-depth biological samples and clinical phenotyping, which is unmatched anywhere in the world. His team target the prevention of immune-mediated diseases in the modern environment. He's also the Foundation Co-Chair of the Children's Inpatient Research Collaboration of Australia and New Zealand, and led the establishment of the Adrian Costa Clinical Trial Centre in Geelong, and the Pregnancy Research and Translational Ecosystem in the southwestern region of Victoria. Please join me in welcoming Professor Peter Vuillermin.
Thanks, Ingrid, and the whole team for the opportunity to speak today. I think these are just such important events and kind of my favourite thing to speak at, because you know you're looking out into this audience full of bright young minds, and it's really nice to be here with you. It's a beautiful winter's day on Windjuri country, and this is a great opportunity to think together about how we make the world a better place. I'm a scientific advisor to a biotech spin-out that's relevant to some of the technology I'll describe. So on your left, we have a bacteria called Vibrio fischeri, which uses a mechanism called quorum sensing to identify when there's enough of them in the room. And when that occurs, it turns on a gene that makes the bacteria phosphoresce. And the question is, why does it do that? Well, it does that because it's under contract with the Hawaiian bobtail squid, which sleeps during the day and then at night comes out and fishes in about 1.5 meters of water. And the Vibrio fischeri are in little chambers underneath the squid. And the squid has a light sensor on its head that allows it to match the ambient light coming from the stars and the moon to the light that it's releasing from the light chambers underneath, so that it doesn't cast a shadow. It's like a squid cloaking device. And at the end of the day, the squid ejects the bacteria, they drop down below quorum, the lights turn off and it hides in the sand for the day. Over the course of the day, the bacteria multiply back up, and as the sun sets, the lights turn back on and the squid goes fishing for the next day. I think there are three things about this story that are relevant to being a clinician researcher. The first is that truth is often stranger than fiction and infinitely more interesting and useful. The second is people worked out this beautiful biological story, and if they can work stuff out, we can work stuff out. And the third is that the natural world is a very connected place, and we're living in a time where those connections are being rapidly disrupted. And unless we engage with that as an idea, then we do so at our own peril. You may have seen this. This is the planetary limits model developed by Rockstrom and a group of very eminent scientists, which sort of lays out that there are at least 9 different systems that are critical to the balance of the planet. We're very conscious of climate change, and so we should be, but it's just one of the challenges that we face. Disruptions to the phosphorus nitrogen cycle, which is a lot to do with how we produce our food. And the other one, we point out very strongly, is loss of biodiversity, and that's loss of biodiversity both within the macro ecosystem and the micro ecosystem. And of course, we are seeing in our modern environment a whole range of diseases increasing in incidence and burden, from overweight and obesity, diabetes, osteoporosis, mental health disorders, allergic disease, where I do a lot of my work, but also neurodevelopmental problems like autism spectrum disorder and ADHD, through to bowel cancer and breast cancer. And we're doing more and we're spending more. So there's some data on the left showing the increase per capita in spending on medications. And on the right, the increasing numbers of births by caesarean section. I'm not sure if any of you have read this book, but if you do get the chance, it's really beautiful. It's, you know, there's probably no one else on the planet who's quite so well placed to give a witness statement about changes in the environment over the course of a very long and obviously very distinguished life. And it's confronting, but it's also very optimistic and empowering in that it gives you a real sense of what we have, our opportunity to contribute. And this quote here, I think, is, for me, one of the reasons to go down the path of being a clinician scientist. We're the first generation to understand the problem and the last with a chance to solve it. So being a clinician is fantastic. It's a beautiful way to spend your time, that opportunity to interact with, for me, one child and one family, and go with them on a journey and hopefully make a difference to that child's life is incredibly rewarding. But in a sense, for me, it's not enough, because I know there's a bigger problem at play and I need to be contributing to that. And I guess when we think about what that contribution might look like, for me, the big glaring gap in many instances is primary prevention. We need to get much better at building fences at the top of the cliff so that we can have fewer ambulances at the bottom. So I guess the question we're all left with is, you know, what can we contribute in, you know, in my instance, living in a country at the bottom of the world, at the bottom of that country in a small, a regional centre outside the major metropolitan. What is it that I've got to do, that I can do to contribute? And it's something a little bit different to the type of focus I think I would have if I was based in a major metropolitan centre. The major centres have got lots of incredible assets, incredible intellectual ability strolling the halls, incredible facilities and, you know, technological capabilities that are remarkably exciting. I think what we sometimes overlook, or what is the strength of working outside the major metro, is the opportunity to connect with a community and to work with that community to solve a problem. So I love this picture. This is our annual Run Geelong, which is a community event where pretty much the whole town turns up to run, walk, hobble or wheel themselves around Geelong to raise money for the hospital. And this is our strength. So the advantage that we have is that we provide whole of system, whole of life course care to a large, stable and engaged population. So that's where we need to focus our efforts. And we need to do it, I think, in a way that is very collaborative with the metro centres, who can then bring us the technical capacity to make sure the work that we're doing is truly world class. In all instances, research begins with a piece of clear thinking. And it's rarely that piece of clear thinking just belongs to one person. It comes out of conversations. It's something you develop together. And if you can get to the point where you have an idea that would resonate both with your next door neighbour and the NHMRC, then that's probably the key first step, because that's what you're going to build the whole thing around. When I was developing the plan for my PhD, I had lots of different conversations with lots of different potential supervisors. And I think that was really important in terms of settling on something that worked really well. These were one of the really lovely things about the clinician-scientist pathway, is that opportunity to have mentors and then in time to have mentees. And these, unlike in the clinical space where you often sort of rotate reasonably quickly through units. In the research space, these relationships often last for decades. So I was fortunate to be supervised by Mike South, who some may know, who was one of the very distinguished professors at the Royal Children's Hospital, and Colin Robertson, who subsequently retired but was a professor of respiratory paediatrics. And eventually we settled on a question worth answering was whether parents should start prednisolone at home, but when their child's coming down with an asthma attack instead of waiting for the doctor. And one of the things that was really useful about this arrangement was that Michael thought they should and Colin thought they shouldn't, so I sort of had supervisory equipoise. And that was really helpful in terms of the way we went about the problem. We came up with a strategy to begin with a survey of asthma prevalence and to use that as a recruitment tool. This is probably too small to read. But what we did was we surveyed, in the year before my PhD, we got some seed funding, which allowed us to recruit some research assistants. We surveyed 21,000 children across 89 primary schools. We had an 80% response rate. Embedded in that was a request for contact details. We identified over 1,200 kids who look like they may meet the eligibility trial criteria for our trial, and we telephoned them all. We screened them via the telephone call, and then we came down to a smaller group that I then interviewed, and those who were eligible we enrolled into the randomised controlled trial of parent-initiated prednisolone versus placebo. We had this group of kids involved with the trial for 3 years, and we only had 2 that withdrew over that period. And we had a crossover design so kids could contribute multiple episodes to the data collection. So after 4 years, I sat on my couch in our lounge room and realised that actually everything was in my computer. The data were locked, the analysis had been confirmed, and I just had to press enter, and away would run the script. And you get this beautiful confidence interval. And this was the finding that showed that parent-initiated prednisolone, as compared to placebo, was associated with close to a halving of the rate of health resource utilisation. Beautiful because it's so many people that have contributed over such a long time to something that is actually really useful. So I yelled out to my wife, "It worked!" And she said, "What?" And I said, "My PhD." And she said, "Oh, that's awesome. Can you put the washing out?" True story. In the halfway through my PhD, I met Anne-Louise Ponsonby, and I think one of the really important aspects of leadership is friendship. It's actually what holds groups together. Is that there's often a couple of really close friendships and trust and having one another's back. And that's a really key ingredient. And my relationship with Anne-Louise has been like that. She mentored me when I was younger, and we've worked together now for coming up to 15 years on the Barwon Infant Study, and it's been a really great experience. And the idea was that we often have basic science and epidemiology, like 2 different tennis players on different tennis courts. And what we really need to do is bring them together, because we need the cutting edge discoveries, but we need to put them in a real world context. So the Barwon Infant Study, or BIS, was designed to put basic science in an epidemiological framework. And we realised that to do that, what we really needed to build was a large, unselected birth cohort with very detailed biobanking through pregnancy and early life, and a whole range of variables. I think this is one of the key things about research leadership too. It's the combination of smoke and mirrors and vanilla slice early on. So we had this uncomfortable period, I think, of about 4 years where we had this great project that we were talking up and that we were trying to build momentum in, and a couple of case reports from it at that point, and that was about it. So there is this point in research leadership where you really have to hold your ground and say, this is a great idea, even though it may not feel like there's a lot there that's actually occurred yet. The vanilla slice is about the relationships you build. So we spent a long, long time taking lots of vanilla slices to all of the midwives' handovers and presentations so that we could have this very strong engagement with the midwifery team. And this was our design principle. People would come along to us with other things that they wanted to do within the context of the Barwon Infant Study, and we'd carefully consider their merit and their feasibility, and then generally we did them anyway. So we took on a lot of different things within the project, perhaps at our peril, but in the end I think it worked out to be the right thing. It was part of the way that we managed to keep the project funded. So we started out with, in an unselected cohort, looking at eczema, then we brought in food allergy, then asthma, then neurodevelopment, then cardiometabolic health, and they led to a series of NHMRC grants, 15 now in different areas. What's also been good about that is that it's harnessed, I think, the Medici effect, which says that some of the really cool stuff in science comes out at the interface between different lines of investigation. So it started as this is a picture of one of our registrars, now consultant's wife and his puppy, and the Barwon Infant Study started out as a little puppy, and it got bigger, and then it got really big. And these are our 1,074 beautiful babies who are part of the cohort. We had very high biosample collection rates because of that engagement with the midwifery teams, and my clinical role was helpful there because I was attending the deliveries. 81% retention to 10 years, and with all of the different lines of investigation, we've ended up with over 150,000 variables per mother-infant dyad. So a very detailed biobank that's been combined with a lot of physiological and clinical measures. So lung function testing, we had to try and get 1,000 babies into natural sleep and then put that mask on their face without them waking up, which took some doing. Skin prick testing and food challenges, cardiometabolic measures. This is us measuring the aortic intima media thickness because babies don't have a neck, so you can't do their carotids. Physical activity measures. This is my little boy who around this stage said to me in front of his kinder teacher, "Dad, can you stop taking me to work to use me for experiments?" Fortunately, they didn't call child protection because it wouldn't have been good for my career. And measures of mental health and neurodevelopment. And this is our BizBus, which the community's paid for, and which we're using to now go around to all of the schools and do the 10-year reviews. And it's fun, you know, we've got this team of lovely people involved with the field work. The bus looks great, the kids are engaged. It's a really sort of joyful process. And it's very much the modern cohort, so it's identifying some of these overarching problems that we can see in the modern environment. 40% of the mums had a BMI greater than 25 with all the complications associated with that. The babies were big, birth weight of 3.5 kilos. 31% of the babies were born by C-section. Actually, that rate's up to 40% now in Geelong and in many parts of Victoria. Half the babies were treated with antibiotics within the first year of life, and probably in many instances on not very strong grounds, and that's among the highest rates in the world, and that's concerning. Half the babies have had a wheezing illness in the first year of life, and almost 1 in 10 have got challenge-proven IgE-mediated food allergy at 1 year of age. What I haven't put on there is recent figures that we've got, which are also very concerning, where the parents have reported that 9% of the children have been diagnosed by a doctor with autism spectrum disorder, 11% with attention deficit hyperactivity disorder, and 15% have been diagnosed with anxiety by a health professional. So they are parent-reported metrics that need to be validated, but nonetheless they tell us that there are problems in the modern cohort of kids. We've been interested in food allergy because it's really increased in prevalence, because it's early onset and you can measure it well, which is not always the case in the case of something like asthma, and because it's kind of the canary in the coal mine in terms of it telling us that there's something that there's an element of immune dysregulation early on. interested in the microbiome, I'm sure you're aware that we're mostly just transport mechanisms for bacteria, 10 times as many bacteria as there are human cells, 100 times as many genes. And in the same way that we are seeing this depletion of the ecosystem more generally, so we see depletion of the ecosystem in the human microbiome. We've been particularly interested in a group of bacteria called Prevotella. And the reason for that is that Prevotella are kind of the archetypal ancestral microbe, a microbe that we've co-evolved with, that are where carriage is ubiquitous if you look in a community of humans living in a very traditional environment. So if you look at the Hadza in Tanzania, or some studies done in tribes in Burkina Faso who are living a sort of hunter-gatherer lifestyle, everyone carries Prevotella. And the more westernised you get the environment, the lower the rates of Prevotella carriage are. And Prevotella are an interesting group of bacteria because they are one of the key bacteria that take plant-derived fibre and metabolise it to produce short-chain fatty acids. And short-chain fatty acids have very potent immune modulatory, anti-inflammatory effects primarily locally in the gut, but also systemically, and they can cross the placenta and they can affect fetal immune and brain development. They also, being gram-negatives, have LPS in their wall, which has important immune stimulatory properties that can affect fetal immune development. So this was after about 8 years into the study where we'd assembled these 1,000 families. We'd done the skin prick testing and we'd collected poo samples during pregnancy and then through infancy. At a year of age, we'd done all these skin prick tests, we'd done all these food challenges, we'd identified 61 children with challenge-proven food allergy. We then went back into the freezer and pulled out the maternal samples from during pregnancy, and we used molecular techniques to identify which bacteria were present in the two samples. This is our bioinformatician, Martin Healy, emerging like Andy Dufresne in The Shawshank Redemption from the bioinformatic pipeline. If you're wondering what that was about. And this is a volcano plot. So this is comparing the mothers of children with and without subsequent food allergy. On the x-axis, you've got the magnitude of the difference between the mothers with and without food allergy, and on the y-axis you've got the strength of evidence. And an OTU is a sort of mathematically defined cluster that tells you, allows you to infer which bacteria are present. And what you can see is that there's these two OTUs that really stand out. OTU 41 is a perfect match for Prevotella copperi, which we then we then confirm with PCR in the complete cohort. And 697 is just 8 base pairs different, so either an allele, a minor sequencing error, or a strain variant. So very strong evidence to support our hypothesis. What predicts Prevotella carriage? We thought it was going to be diet, but actually what came out really strongly in our diet, in our data, was household size. This was really interesting because it brought us back to the hygiene hypothesis, which was based on the fact that people who came from larger households were less likely to get hay fever. And it makes sense, doesn't it? The closer we hang out together, the more we share our commensal bacteria. What about postnatally? And we're seeing a really similar sort of picture emerge. So this is Yuan Gao, who's probably the PhD student who's told me I'm wrong the most in my whole career and therefore my favourite. She's done, not that I have favourites, but she's been great. She's done this lovely work where she's looked at the DNA from the faecal samples collected from the babies at 1, 6 and 12 months of age. And she's related those data to the baby's chronological age, and she's created this microbiota maturity for age Z score. And using this, she was able to show that having more siblings was very strongly associated with having a more mature microbiome at age 1, and in turn, a more mature microbiome at age 1 was strongly associated with the absence of food allergy. And then what she was able to show in a formal mediation analysis was that over 60% of the protective effect of having siblings on the risk of food allergy was being mediated by this increased maturity of the gut microbiome. And that's a really big number in a mediation analysis. We often see numbers sort of less than 10, 20%, so greater than 60% is very striking. So that's exciting, and it's also exciting because we're seeing the same metric emerge in 2 different European cohorts as protective for subsequent asthma, and we also see the same signal for subsequent asthma within our cohort. So I guess the question is, how do you go from that to making a difference? And I think it's important to think ambitiously, not to you need to sit down with a group of people and think, well, how could we make the biggest impact with this piece of work? So that's taken us to establishing CIRCAN and the ARROW trial. This is Sarah McNabb, who's the Director of General Paediatrics at the Children's Hospital. She's fantastic. She started CIRCAN and she and I co-chair it. Our hospitals are full of kids with preschool wheeze or preschool asthma. It's the most common reason kids are admitted to hospital, and we have nothing that will reduce the risk of readmission, which is about 30% per annum. What we are testing is a bacterial lysate on the premise that it's this diversity of microbial experience that's driving a healthy pattern of immune development. OM85 has actually been around for 3 decades in Europe, and it's a concoction of 21 strains of bacteria from 5 separate respiratory pathogenic genera that have been killed, that the kids take orally, and which stimulates the immune system so that they respond effectively to a viral infection, and they also have efficient regulatory T cell responses in their lungs to prevent excessive inflammation. With CIRCAN, we've now got 42 sites across Australia and New Zealand participating in the trial. We've established a novel model where they are referring rather than recruiting the kids into a central team based in Geelong, but really virtually. And the entire trial is run virtually, enrolment through to completion. And with that, we hope to deliver a trial of 2,300 children over the coming 3 years. It's all going very nicely. We've got this really great team of junior doctors helping us with the online recruitment process, and they're based in different parts around Australia. There's a very strong background for why we think OM85 will be effective. The exciting thing is that if it is, it's not available in Australia and New Zealand. We've got really widespread end user engagement in what we're doing, and so the translation pathway will be really quick. And from an environmental point of view, one of the things that I find exciting about this is that each MDI, each metre dose inhaler, is the equivalent of 300 kilometres of driving, because the propellant they use in them is a terrible greenhouse gas. So one of the ways that we contribute to environmental protection as clinician scientists is to reduce the burden of disease. This is Jess Costa-Pinto, who's a mum, a paediatrician, and doing a PhD within the ARROW trial, getting a prize at the 3-minute thesis last year. She's terrific. Sometimes leadership looks like a chat above a fruit shop. And this is the Costa's fruit shop in Geelong, where Francis Diver, who's our CEO, and I met with Robert Costa and talked about the community benefit that would come from establishing a clinical trial centre in Geelong. The Costa family subsequently made a very generous donation, and that's allowed us to move from a sort of siloed pattern of clinical trials in Barwon Health to a centre that delivers an overarching system and infrastructure, and there's now more than 150 clinical trials underway. Our hospital executive, I think we're lucky. We've got a CEO and an exec and a board who are really very committed to the idea of growing Barwon Health and Deakin University as a centre of excellence in research. There's been some significant financial commitment to that, but also a sort of cultural commitment. This is what our ecosystem will look like. We want people to be able to go from idea through the full journey to translation and impact. A key component of that, which may be of interest to you folks, is we're about to launch in the coming week the Barwon Health and Deakin University Clinician-Scientist pathway, where we will have an initial tranche of 10 places. It's a 4-year program. You'll be 50% clinical, paid at a clinical salary, and 50% PhD with a PhD scholarship, on the premise that there needs to be a very strong synergy between your clinical role and the PhD. And we think this is a really good way to create opportunities to grow clinician scientists in our region. And it's great to see both the health service and the university generously contributing to this. It's also a nice place to live. As was mentioned earlier, one of the nice things about research is it takes a village, and it's been a very big village involved with this, the work that I've presented. And the most important acknowledgement of all is always to remember what N really equals, which is a whole lot of families that give us their time and trust.
Thank you, Professor Vuillermin. We have time for perhaps one question. So if there are any questions, please raise your hand.
I think the question is, what's for lunch?
If anyone does have any questions or thinks of one while eating the beautiful lunch being provided, perhaps find Professor Vuillermin and ask him then. Just before you all go, lunch is now offered and the spot mentoring will begin at 12:50 p.m. Please see Katie, who is over there, but you will also find her outside the door of the auditorium 1 minute before your scheduled sessions, and the sessions will be held in here, but please meet her out there. Thank you so much, and please say thank you to Professor Vuillermin once more.